we're going to do some tips and tricks for question 6. That's the one that it looked like you guys struggled the most with. That's the one that got the most votes for us to go through. So there is where we are going to be starting. Okay, let's go and have a look at our question 6. All right, in question 6, it looks like we have a parabola, all right, and we have our exponential graph going through there, and we need to work some stuff out. Okay, so what kind of tips and tricks can I give you for this kind of question? Well, first of all, when you're doing this kind of graph, all right, or this kind of question, I always suggest to students that before you even start this question, go and work out what you've got here, okay? Go work out what you've got. So you've got a parabola, it's a sad face parabola, okay, it's going down, all right, and you've got an exponential. It says to you that the graph F cuts the x-axis at A and C, okay? So I'm going to grab my pen quickly. All right, so there's my graph of F, okay? It's cutting at A and it's cutting at C, and my graph of G, there's my graph of G, is the exponential graph. 2 is a half is to x plus 1 minus 4, okay? Graph F cuts the x-axis at A and C and y-axis at E. So there he is over there, and has a turning point of D. All right. Graph G cuts the x-axis at A. All right. So we got a point where they're intersecting each other. Okay. And the y-axis at B. All right. Now, let's go look at my graph. Okay, my questions. I'm going to get the same questions coming up over and over and over again. You know they're coming. You're going to get things like, what is the y-intercept? What are the x-intercepts? What are the turning points? You know they are coming. So make sure that you know all the different formats of your graphs, guys. Okay, that's what's really important here, for you to understand and for you to practice all the different formatting of your graph. So for 6.1, it says to you, write down the asymptotes of G. So now, what does an asymptote mean? An asymptote is the line, okay? It's the line which the exponential graph is not allowed to cross. So I'm going to go and I'm going to make it a little bit clearer here. They've drawn it in, but it's not very clear. There it is over there for us, okay? How do I tell what my asymptote is in my equation? I always go to my equation, okay, and whatever is sitting on that side over there, that is my asymptote. So in other words, for 6.1, my asymptote is going to be y is equal to negative 4. And straight away, I can actually go and I can write this in here, negative 4. So I'm helping myself out a little bit. Okay. All right. For 6.2, they're asking me for the coordinates of D. So like I said to you, same things they're asking me for again and again and again. All right. What is D, guys? They told me earlier on, D is the turning point. Okay. They've been quite kind to me here. All right. If I look at the format of the equation that they've given me, okay, they've actually given it to me in the right format to find my turning point. So for this one, I know that my turning point over here is going to be 3 is to 25. If they hadn't given it to me in that right format, I would need to go, I would need to complete the square, okay, or I would go and need to use my formula to help me find that. But in this case, I don't need to do that. They've given it to me. Okay. Kristen's asking me, is it y because it's on the y-axis? Yes, Kristen, remember that when you're looking for your asymptote, all right, remember that your asymptote is a y asymptote, all right? It's going horizontal, and any asymptote that is horizontal, all right, I always used to teach, not always used to teach, when I teach the grade 11 lessons, okay, I always say you've got this, and you've got hoi, all right. So if you've got a vertical line, so a line that's going that way, okay, it means that your gradient is undefined. That's what the U stands for. And so what's going to happen, you're going to have an equation that's going to be x is equal to something. If you've got a horizontal line, it means that your gradient is equal to 0, and it means you're going to have y equals something. Vix and Hoy. All right. Kanye is asking, what about the negative sign by 3? Remember, Kanye, when you're completing the square, you're always going to have a negative here. Okay, that's what you're going to have. That's what you get when you complete the square. Okay, when you're looking at your turning point here, you can quite clearly see that the 3 is on the positive side, not on the negative side. Okay, so the 3 has to be positive. Remember what the standard form for that equation is, all right? And so it's going to have a negative there, but your 3 is going to be positive. Okay. All right. So for this one, we're going to have 3 is to 25. All right. My next question says, write down the range of f. Write down the range of f. Guys, what does range stand for? Well, you get two different things. You get domain, and then you get range. I used to struggle with that when I was in school. I was like, how am I going to remember which one's domain, which one's range? Okay, you can learn it off by heart. That's fine. Or you can think of it as range has this G in it. And so I always used to think that the G kind of reminds me of having a Y there. So the G and the Y, all right, that helps. Okay, so we're looking for all the Y values of this F graph. Okay, so what is the range of the F graph? Well, where does this F graph start? This F graph starts at 25. Okay, so that's the ultimate place. It starts at 25. That's the topping point. It can't go any higher than 25. However, what happens? It's a sad face, hey? It's a sad face, which means it's going to go all the way down into negative values. So there's two ways that you can write this, guys. If you're writing the range of it, you can either say y is less than and equal to 25. Why equal to 25? Because that's where it starts, all right? Or you can say, okay, y is an element, round brackets, negative infinity. Why round brackets? Because if you're going into negative infinity, that's not a definite point. It's just going on and on and on and on and on forever into infinity, all the way to 25. And that is where it's going to stop. Okay. Any questions on the range? Are we good? Does that make sense? All right. Next question. Calculate the length of EB. So they want to know, how long is this line from E to B? Always good to tell yourself, okay, what is E, what is B? So E is the y-intercept of graph F. B is the y-intercept of graph G. If we can go and we can calculate what those intercepts are, all right, then we're going to be able to have some values there. All right. Going back to the chat very quickly, Kirsten is just asking me for the last question. Is there a reason why it's a round and a square bracket? Kirsten, the reason why it's a round and a square bracket, it's a round bracket by negative infinity because that's not a definite value. So negative infinity is not a definite value. It's just a value that's going on and on and on and on into infinity. It's not given a definite point. However, 25 is exactly where that graph is starting. It is starting on 25, which means it gets a square bracket. Okay, I hope that makes sense for you. All right, I'm going to go and I'm going to insert another page here, guys, so I have a little bit more space to work on. All right. So on my other page, okay, let me go and grab this question very quickly. I want to take both of my graphs across. All right, so I want to have a look at my f of x and my g of x. Those are the two things that I'm wanting to redo. So for 6.4, okay, I want to write the f of x graph. So f of x is equal to negative, it's a negative parabola, x minus 3 squared plus 25, and g of x is equal to 2.5 x plus, x plus 1 minus 4. So like I said to you guys, if I can find out what point E is, and I can find out what point B is, I can then go find the distance for that line. All right. I said to you, point E was the y-intercept. Okay. What happens at the y-intercept? I know that x is going to be equal to 0. So at the y-intercept, x equals 0. All right. Having f of x is just a fancy way of saying y. All right. So I'm going to start here. I'm going to go say y is equal to negative 0 minus 3 squared plus 25. What have I done? I've gone and I've replaced. Instead of seeing x, I'm seeing 0. Okay. There's some people that will go and tell you, oh, you must use f of 0. Yeah, you can go do that. That's fine. That's the fancy way to do it. You're more than welcome to go do that. All I'm trying to find out here is, what is my y-intercept? That's what I'm doing. Okay. Carrying on, y is equal to negative 3 squared plus 25. I'm going to stick that on my calculator because I know in the exam I'm going to be stressed out, and I'm going to get y is equal to 16. So therefore, E is the point 0 is to 16. Okay. I'm then going to go do my point B. All right. So for point B, I'm going to have y is equal to 2.5 to the power of 0 plus 1 minus 4. So y is equal to, I'm going to put that on my calculator. Okay, I'm going to go stick that on the calculator, and I'm going to get negative 3. Okay, please don't forget your calculator on the day of the exam. All right. So therefore, B is the point. 0 is to negative 3. Okay. If it's really not making sense to you, all right, then how to get the distance between those 2 points, go draw it on your graph. All right, go draw it on your graph. Or you can say to yourself, therefore, EB is equal to 16 minus negative 3, which gives you 19 units. I'm going to go draw it on your graph for you as well, so you can have a look. Oh dear, sorry. So there's my graph. Okay. This was 16. This is negative 3. So from 0 to there is 16. From 0 to there is 3, or negative 3, but 3. So 16 plus 3 gives me 19 units. Do not forget to say the units. Ma'am, why do we say minus? We say minus because we're going into the negative. So because we're going into the negative, we say minus. It just makes it make sense. That's all. All right. 16 minus negative 3 because we're going into the negative. That's all. Okay. You could say to yourself 16 plus 3. Same thing. It's going to give you 19 units. All right. Okay. You could just go straight to 19 units as well. Therefore, EB equals 19 units. That's perfectly fine. As long as you've shown you're working on how you got E, as long as you've shown you're working on how you got B, and therefore EB equals 19 units. Perfect. Okay. All right. 6.5. Determine values of x for which f is decreasing. Okay. Determine values of x for which f is decreasing. Sorry. All right. So guys, if we're looking for increasing and decreasing. Okay, let's go have a look here. All right, so let's look at our graph. Okay, when we look at this graph, all right, all the way moving along, I'm going to go pick a different highlighter quickly. So as we go, let's start from this point here. Let's make it a smaller highlighter. As we start from this point here, as we're going up this graph, okay, so as we're going along this graph, all the way this way, what's happening on this graph? This graph of f, which technically when we're talking about f, it's actually y. I know it's super confusing sometimes, okay? But as we're going along this graph, okay, and we're moving along the x values, what's happening as we're going like that? The graph is going up, which means it is increasing. And it's increasing and increasing until we get to this point over here. All right. When we get to that point over there, it stops. It becomes stationary. All right. The graph becomes still. And then it's almost like a roller coaster. All right. We get to this point, and all of a sudden, what happens at this point? As we're moving along with the x values, okay, we start going down. Okay, the y values start to go down. All right, so as we move from this point to this point, okay, so as we move along with our x values, what happens to our y values? They go up, up to a point, and then they start to decrease. All right, so what they're asking us in this question is they're saying, determine the values of x for which f, the y values, are decreasing. Okay, so they're definitely not going to be from this point over here where we started. All right, they were increasing. They stopped. Where did they start decreasing from? They started decreasing from the 0.3. Okay, so here we go. They started decreasing from the 0.3, so x must be greater than 3. Okay, or you can say x is an element, all right, from round brackets. Why round brackets now? Because technically it wasn't on the point of 3, all right? On the point of 3, what was happening on the point of 3? On the point of 3, it was stationary, it was stopped, it was 0, there was nothing happening. Just after the point of 3 is when it started decreasing. That's why we don't have greater than and equal to, we just have greater than, and that's why we have a round bracket. So round bracket 3 all the way to infinity round brackets. All right. Okay. Jade is asking me, ma'am, can you please repeat the step after we find the coordinates for E and B? So that was for the previous question. So Jade, I said either you can go and draw the points on your actual graph and then go see what the distance is. So from 0 to 16 was 16 units. From 0 to -3 is 3 units. So 16 plus 3 gives you 19. Or you can say to yourself, you can write in the sum, you can say 16 minus, why minus? Because you're going below 0, minus -3 gives you 19. Either way, same thing. Either way, same thing for the previous question. Okay, either way, perfectly same thing. All right. Okay, guys. 6.6. 6.6. Calculate the average gradient between points A and points B. So calculate the average gradient. I'm going to go do some erasing here quickly so we can see what's going on. Because now my graph's got loads of color on it. Just need to see points A and points B. Okay, so they want to know, what is the average gradient between point A and point B? Well, I know what the coordinate of point B is. We worked it out a little bit earlier on. The coordinate of point B was 0 is to -3. Okay, so I know what the coordinate of point B was. The coordinate of point B was 0 is to -3. We calculated that. Okay, what are we missing? We're missing the coordinate for point A, hey? We're missing that coordinate. Now, that coordinate is not difficult to find. It's either you can say it's the x-intercept for the parabola, or you could say it's the x-intercept for the exponential graph. If we're going to go make it the x-intercept for the parabola, we're going to have two figures. It's going to be complicated. Ugh, so difficult. I would rather make it the x-intercept for the exponential graph. It's going to make our life so much easier. We're only going to have one figure that we need to calculate there. So that's how I would calculate it. But if you want to go do it as the parabola, you're more than welcome to do that as well. It's not a problem. Okay, it's not a problem. All right. So for 6.6, I'm going to go take my equation for the parabola. So I'm coming back to my working out page here quickly. So 6.6, I need my equation for that exponential graph. So I've got y is equal to, I like using y, you can use the g of x, that's fine, not a problem, is equal to 2 to the half x plus 1 minus 4. Okay, I want to know what my x-intercept is. When I'm calculating my x-intercept, I must always make y equal to 0. So I make it equal to 0, 2 to the half x plus 1 minus 4. Okay, take the negative 4 to the other side, guys. So I've got 4 equals 2 to the half x plus 1. Right. Divide both sides by 2. So I've got 2 equals a half x plus 1. Got options here. Okay, I can either make them both have a base of a half. That's a possibility. Okay, or I can have them both as a base of 2. I like to have them both as a base of 2. Either or, though, it's the same thing. Okay, so let's take them to a base of a half. Same. All right, so instead of having a 2 here, oh, sorry, guys. I'm going to change this 2 and I'm going to make it a half. When I do that, the exponent becomes negative 1. Okay, so in other words, a half to the negative 1 is the same thing as saying 2. Okay, which equals a half x plus 1. Now the bases are the same. Same base, I can drop the bases. So I've got negative 1 equals x plus 1, right? X is on the one side, numbers on the other. Take that to the other side. Negative 2 equals x. Okay, in your solution, I've done it the other way for you. Okay, so in the solution, I've done it the other way for you, so you guys can have a look at doing it the other way as well. All right, it's there for you. You can have a look. Either way is perfect. You get the same answer. All right, so let's go back here. So this point is now the point. Negative 2 is to 0. Okay, so they're bringing in a little bit of paper 2 there, kind of. All right, because now we need to do average gradients, and that's technically paper 2, but you know what? They're allowed to do that, guys, because you've got a formula sheet. So now we've got two coordinates. We've got point A, which is the point negative 2 is to 0, and we've got point B, which is the point 0 is to negative 3. All right. I'm going to say here x, y, 1, 1, 2, 2. So m is equal to y2 minus y1 over x2 minus x1. y2 was negative 3 minus 0 over x2 was 0 minus negative 2. Okay, and I'm left with negative 3 over 2. All right, so I took my formula, okay, took my 2 points, labeled them out for myself, put it into the formula, substituted it in, all right, worked it out, and I got that m was equal to negative 3 over 2. What would I suggest you do, though? Because what happens in the exam? You get super stressed, all right? You start getting your negatives and your positives all mixed up. I would really suggest you take that and you put it on the calculator. Okay, so sub it into your equation and then put it into the calculator for you to help yourself out. All right. Anyone who's confused about how to do the average gradients? Anyone who's confused about average gradient, guys? Are we good on average gradients? I know it's a little bit of paper two. I know that. I know it's a bit of paper two, but it's one of those, you could technically say it's like a level 3 question. Remember we spoke about levels? So it's kind of like a level 3 question inside of your paper one. All right. Okay. If we don't have any questions, we are going to move on to the next one. All right. No one has any questions. No, all good. Leave it up for a few more seconds. On 6.6, can I repeat from step 5? Step 5. 1, 2, 3, 4, 5. I'm not sure which step that is. You're gonna have to explain to me which step that one is. So just tell me, is it where we calculated the points? Was it where we put it into the equation? You just need to explain which step you mean. Where did we lose you? On dividing by 2. On dividing by 2. Okay, so we weren't dividing by 2. We were taking our 2 points. So we had 2 points there. Okay, all right. When we had those 2 points, we then took those 2 points, we substituted them into the gradient formula because we were looking for the average gradients. Okay, because we're looking for the average gradient, we're not dividing by 2. What are we doing? We're substituting your 2 points into the average gradient formula. So we're not dividing it by 2, okay? We're subbing in our points. All right, that's what we're doing, not dividing by 2. Okay, so after we didn't divide by 2, maybe you are talking about all the way up here when we calculated. Is that maybe what you're talking about? Yes. Okay, so let's go back here for you quickly. All right. So this you would have learned how to do in grade 10. We'll go over it again quickly for you. All right, so let's go here quick. Okay. All right, so coming back here. All right, we divided both sides by 2. So we got 2 is equal to a half to the power of x plus 1. Now we need to find the same base and the same base, okay? So that's what we need to do when we're solving exponential equations. All right, so either we can make the base 2 on the one side, which we already have, and 2 on the other side. I don't like working with those negative exponents though, and then I have to multiply everything out. So what I was saying that instead of taking the half and making that into a negative, I said 2 is the same thing as saying a half to the power of negative 1 is equal to a half to the power of x plus 1. Now I have the same base and the same base, so I can drop my bases and I get negative 1 equals x plus 1. Right, I take my 1 across and I get negative 2 equals x. So therefore, A is the point, negative 2 is to 0. Okay, I hope that makes sense to you. If you're still not sure, you need to go back and you need to practice those exponential equations. All right. Okay, somebody is asking, can you teach us how to get the x value on the parabola? All right, so I'm going to show you a cheat way. Now that you've got that one is negative 2, all right, the value between negative 2 and 3, okay, the distance between negative 2 and 3 is 5 units. So you need to have the same distance between D and C. So 3 plus 5 is going to give you, let's see, it's going to go give you 8 is to 0. So what you do is you say to yourself, I'm going to do it again quickly to show you the cheat, all right? You say to yourself, this is the halfway point. This halfway point is 3. From -2 to 3, there's 5 units. So 3 plus 5 gives you 8. And so you get 8 is to 0. Done. All right, so that's how you get the point for C. Okay, I don't think they've asked you in this question though, okay, because it's a really nice, easy way to do it, and that's probably why they haven't asked you to do it. Okay. All right, next question, guys. They say, graph T is obtained by reflecting G about the x-axis. Okay, graph T is found, okay, obtained by reflecting G about the x-axis. Write down the range of T. Now, if we are reflecting about the x-axis, what's going to happen? All right. Well, the y values were previously positive, and what's going to happen now? The y values are going to become negative. So again, if we're reflecting about the x-axis, put your hand on the x-axis. Okay. If the graph was above the x-axis, all right, if we're reflecting about it, then now they're going to be negative. If they were negative, now they're going to be positive. That's what happens when you reflect about the x-axis. Okay. Whatever happens, it's going to change the value of the graph. All right. So in other words, it means, okay, what it means is that the graph of T of x, you can take that graph of T of x, okay, and whichever way you look at it, you're going to take your G of x graph, which is the graph you're looking at, and you can multiply it by a negative. All right, so when you reflect about the x-axis, it's going to change the value of the G of x graph. That's what happens. You put your hand on the G of x graph, okay? On the x-axis, okay? And you tell yourself, what's happening? My y values are going to change, okay? They're either going to become negative or they're going to become positive. So you're going to take your axis, your G of x graph, and you're going to times it by a negative. All right. That's going to reflect the values of the graph, because if it's positive, it's going to make the whole graph negative by timesing it by negative, and if the graph is negative, when you multiply it by negative, it's going to make the whole graph positive. So that's the easiest way to do it, all right? Multiplying it by a negative. Okay, so we move on. We say T of x is equal to negative. What was the G of x graph? It was 2 of a half to the power of x plus 1 to the negative 4. So T of x is equal to negative 2 to the half x plus 1 plus 4. Okay, so where the whole graph was going like this below, now it's going to go the other way. All right, it's being reflected. Okay, the remainder of that question says, all right, write down the range of T. So they also want us to write the range of T. Now, when we're looking at an exponential graph and we're looking at the range, what do we now know? We now know that we have a new asymptote, do we not? The new asymptote is now going to be y is equal to 4. How do we know that? Because look, it changed. There's the new asymptote. The new asymptote is y is equal to 4. So now the range of this graph is going to be y must be less than 4, or we can say, okay, y is an element from negative 4 all the way, sorry, not from negative 4, from negative infinity, apologies, from negative infinity all the way to 4. Why round brackets? Because it's not allowed to touch the 4. It's just before the 4. All right. Finishing off. 6.8. If P of x is equal to that, write down the coordinates of the turning point of P. Okay, so if P of X is f of X plus 2, all right? So the whole of the f of X graph plus 2, write down the turning point of P. Well, guys, is that plus 2 going to affect the X point? No, it's not. It's going to affect the one of the Y. So therefore, okay, if we looked at the previous coordinates of the turning point, here it was up here. There's those previous coordinates over there, okay? My new coordinates are going to remain the same for my X. They're still going to be 3. What's going to happen to my Y? It's going to be 27. We're going to add 2 to the Y. And finally, the last question here, it says, determine the value of K for which that straight line will be a tangent to F. So the values of K for which that straight line will be a tangent to F. All right. This is for 4 marks. Okay, so this is the one that requires a little bit more work than before. Let's go do it quickly. 4 marks, 4 minutes. 4 marks, 4 minutes. 4 marks, 4 minutes. Okay. All right. Give ourselves a little bit more space. So I've got f of X is equal to negative X minus 3 squared plus 25. First thing I want to do is I want to expand this a little bit. Okay, so I'm going to go say to myself, I'm going to take out the f of X. I hate saying f of X. I'm going to say y is equal to negative X squared minus 6X plus 9 plus 25. So I've just taken that bracket and expanded it. Y is equal to negative X squared plus 6X minus 9 plus 25. Y is equal to negative X squared plus 6X. What have we got? Oh, sorry. Going crazy here. Yeah, no, I'm right. Still right. Sorry. Plus 16. Happy so far? All good with where I am? Cool. All right. Now, okay, that graph that they wanted me to make a tangent, okay, was y is equal to 2x plus k. Where the two graphs are a tangent, it means that it's touching at one point. So that means I can do the following. I can go say, therefore, negative x squared plus 6x plus 16 is going to be equal to 2x plus k. So I'm going to make them equal to each other because that's where they're going to be a tangent. It's where they're equal to each other. They're touching. All right. Okay. So a tangent, okay, has one point of intersection. So one point where they're going to be touching. Do you agree? Okay. It only has one point where they're going to be touching. Are you happy with that? Yeah? Okay. All right. So I'm bringing this across. I've got negative x squared plus 4x plus 16 minus k is going to be equal to 0. Okay. All right. Okay. So if a tangent has one point of intersection, it must mean that it has two equal roots. So it must mean that it has two equal roots. Okay, somebody's asked me, why did we first multiply by the negative sign? Why did we first multiply by the negative sign? I am not quite sure what you meant there, Tando. All right, yeah, not sure where it is that you are talking about. If you can maybe go back and let me know where it is that you're a little bit confused or you might be lost, then I can go back, but I'm not sure where it is that we lost you there. Okay, with the negative sign. Okay. So, all right. What it means by if we, sorry. Yeah, let's go back. Okay, so if we have two equal roots, all right. So for us, if we go back to our graph, sorry, pen's going flat. All right, let's go back to our graph. Okay, on our graph, all right, we have a whole range of different numbers that we can use. Do you agree? Okay, so a whole range of different figures and different numbers that we can use to try and calculate this, all right? But the two figures and the two equal roots that we're going to use here, right, are the figures x is equal to 4 and x is equal to -1. So we're going to have 4 squared. Before I do that, let's just calculate this quickly for you. So let's get rid of the negative. So we've got, apologies, I'm skipping steps here, x squared minus 4x minus 16 plus k is going to be equal to 0. Okay, now we can go from here. All right, so if we're doing it this way, why did I miss out a step, guys? Why am I losing my mind here? Feel like I left a step out. No, I didn't leave a step out. Sorry. Wait, yes, no, apologies. Okay, all right, back to my thing. All right, so in this case, we're going to take that x is going to be equal to 4, hey? So we're going to have, right, 4 squared minus 4 to the 4 minus 16 plus k is going to be equal to 0. So I'm going to have 16 minus 16. Listen, it's not working. Sorry, guys. Mr. Hugo, have I left a step out somewhere? Can you see?
I am also having a deep look now. I don't
Yeah.
know if line.
Okay. Wait. All right. Tangent has one point of intersection and thus has two equal roots. All right. I'm good. I'm good. Guys, is there somebody that wants to help me out here? Maybe I am losing my mind. I'm going back to my question. Straight line is a tangent to f. So here is my straight line. That's all good. 2x. So we're going this way. All good. All right. That's all good. Cool. We can't have negative values. That's all good. Okay. I don't know where I got my equation from here. All right. Guys, I might need to come back to this one. My brain has gone blank where I got my equation from. I know I'm going this way. I know that I've got 2x, so he's going this way. All right. Sorry, I'm going to draw him in here. So I know he's going like, I'm going to draw him in. I know he's going like this. Like that. I just need to work out where he was. Sorry, let me draw him in again. I know that I had him, sorry, like this. Like this and like this. I just can't work out where I got him from. 20, I know that, yes. I'm so sorry, guys. I can't work out where I got my figures from. I think I made a mistake somewhere along the line. Anyone who wants to help me? Is this a higher order question? Yes, Josh, it is most definitely a higher order question, and that's why on this Saturday I am struggling a little bit for you. I will come back to you with an answer. Can we move to our paper 2 in the meantime? And I promise we will come back. So far, we have managed to get, I will tell you how many marks we've gotten from this so far. We've got 2 on 4. We need to get our last two marks here, and so that's where I am a little bit stuck, but we will come back to this one. I want to move on to our paper 2, and I promise we will come back to this one, and I'll have an answer for you by the end of this lesson. All right, so I want to move down to our paper 2. quickly for us, okay? And then we will come back to this, okay? I promise, promise, promise. Right, paper 2, the question that you guys wanted to go through was definitely question 8, guys. All right. Ma'am, it's minus 16. I agree with you, Bali. It is minus 16. I think I put the wrong figure in. I think that's where I'm going a little bit confused. I'll come back to that one, though. I promise. And Bali and Zanele, promise. All right, guys, let's move to question 8 quickly in paper 2, and we will come back. I'm just worried we're running out of time as well. Okay, so let's move to question 8 here. Oh, question 8 is beautiful. Question 8 is geometry. It is my favorite. So let's move to question 8 and let's make our brains work a little bit more. In this figure, Q, P, T, S, and R lie on the circle. M lies on QS such that PM is parallel to SR and PTS is 145 degrees. Right. What do you need to do first? If it was me, I'd pick up my highlighters. Now, you get a whole book to do all your working out in, one of those drawing books, and you get a question paper. Guys, go draw on your question paper. Okay, you're allowed to do that. So, I'm going to go draw my question paper. I'm going to go highlight my parallel lines first. Right. Because I've highlighted my parallel lines, things are going to start becoming a little bit clearer to me, okay? I'm also going to tell myself in the figure, Q, P, T, R, S lie on the circle. So I've got points on the circle. Cool, okay? M lies on QS, such as those two are there, and PTS was 145 degrees. All right, they haven't given me any center of the circle, so I can't use the whole angle at center equals 2 times angle at circumference, unfortunately. All right, what I can use though, guys, is look at this. Let's make some things start coming to life for us before we start doing the questions. Okay, I've got P and I've got S. So I'm going to use my my blue pen to show you some things very quickly. If I go from P and S, can you see that P and S make this angle R? Okay, so P and S are making R. And what else are P and S making? P and S are also making angle Q. So if I've got points, okay, so if I've got angles from a common point, what do I know about that? Angles from a common point are going to be, what do we already know about angles from a common point? Angles from a common point are going to be equal, hey? All right, so we already know that angles from a common point are going to be equal. Do you agree? Awesome. So I already know that I've got this angle and this angle are going to be equal. Okay, so already I've got 2 angles that are going to be equal. I also know that I'm going to have some alternate angles here. So I've got P2 and oh, look at that. I've got R. So that's coming to life for us with alternate angles. Okay. Do I maybe have anything else? Well, look at that. I've got more alternate angles. I've also got M and I've got S. Okay. Okay. Could I possibly do anything with point T? Maybe something's coming a little bit later on. All right, maybe I have a cyclic quad. Just hint, hint, nudge, nudge. I see a cyclic quad too. Good. And Bali and Zanele, I also see a cyclic quad. Okay. I see a cyclic quad in PTSQ. All right, so guys, start making things come to life. That is my hint and my suggestion here. So 8.1 says to us, calculate the size of angle Q. So the first thing they want us to do is they want us to go and they want us to calculate the size of angle Q. All right, so let's go have a look. Here is angle Q. All right, if we're looking at angle Q, like Mbali and Zanele just said to us, we see a cyclic quad. PQST. PQST. What do we know about the opposite angles in a cyclic quad? We know that the opposite angles in a cyclic quad are add up to 180. So I can go and say for 8.1.1, Q is equal to 35 degrees, opposites, angles, cyclic quad. Okay, for those of you who are struggling a bit to see that cyclic quad, I'm going to go highlight it for you very quickly. And do it in green. P, Q, S, T. There he is over there. All right. 8.1.2. I told you it was coming. 8.1.2. Calculate the size of angle R. Well, we already know now what angle R is because we already put it into our head. So 8.1.2, we know that angle R equals angle Q, which equals 35 degrees. Okay? And we're going to tell them, can either tell them angles in same segments, like I showed you guys earlier. Okay, they're made up from those same points. All right. Or, all right, you can use the same things. Opposites, angles, cyclic quad. Somebody's asking me, man, do you not have to prove that it's a cyclic quad? Nope, you don't have to prove that it's a cyclic quad. Okay, why don't you have to prove that it's a cyclic quad? Because they told you that Q, P, T, and S lie on the circle. So they've told you that they lie on the circle, therefore it is a cyclic quad. All right. What's the next one coming up? What a surprise. Angle P2. What did we say was going to come up, guys? We said P2 was coming up. So 8.1.3. 8.1.3. Shocker. Angle P2 is going to be equal to angle R, which equals 35 degrees. Reason. Alternate angles, right? PM is parallel to SR. I told you, if you've told yourself what's happening already, it's going to make your life so much easier. Work out what's happening already. Okay. Last question. Why is PR a tangent to the circle passing through PM and Q? So why, okay, is PR a tangent to the circle passing through those points? All right. Why? Why is that happening? All right. I like to go and draw the circle in there. Okay. I like to go draw the circle in there. All right. So let's go. So PMQ. PM and Q is up on the top here. Right. And they want to know, why is PR a tangent? So here is PR over here. Okay. Why is it a tangent to the circle passing through? Oh, sorry, my circle's a little bit off. P, M, and Q. Okay, it's a really bad circle. All right. Why is it a tangent? Okay. It would only be a tangent if what, guys? It would only be a tangent if, this angle over here, P2, was equal to angle Q. Why? Because, why? Why would that be true? Good, well done, Cassandra, because of tan chord. Well done. So we're going to say, we know, okay, angle P2 is equal to angle Q, which is equal to 35 degrees. We've worked that out all the way along the top there, all right? So therefore, PR is a tangent, okay? Reason, you can call it the converse of tan chord theorem. So it's not the tan chord theorem, it's the converse of the tan chord theorem. Okay, it's the converse of the tan chord theorem. All right. So that was definitely the winner for paper 2. I think what I'm going to do though is I'm going to clear paper 2's responses. I'm going to bring paper 2 up again for you guys. Okay, I'm going to bring paper 2 up again for you guys, and I'm going to ask you guys to respond again. Okay, so Mr. Hugo, if you can share in the chat paper 2, or the, thank you, Mr. Hugo. Mr. Hugo is so quick. All right, so guys, I'm going to bring the slide up again. Go have a look. Go scan for us. Go scan for us, or go click on the link. Okay, go scan for us or click on the link. All right. Go scan for us and click on the link and tell us what other question from this paper do you want to see. So scan or click on the link. What other question do you want to see? And I'm going to show you the results while they're coming up. Okay. I'm going to show you what they look like while you're voting. We're not going to do it for very long because we want to have enough time to go through the actual paper. Okay, go vote. All right, only 7 people, and so far it looks like question 9. Okay, if you can't scan or you can't click on that link, then tell us in the chat. Mr. Hugo will keep track like he said.
Teacher
Okay,
Chris,
so far, yes.
Sorry, we have Cassandra asking in the chat the trig. Which question is the trig? Because she struggled with the trig as well. Or not,
Trig.
she said it was difficult.
There's a few trig questions there, Cassandra. So there's graphs, Cassandra. There's the area and the sine theorem. Which one did you struggle with, Cassandra? There's a whole lot of different trig questions. We did go through one of the trig questions, one of the easier ones. Okay, which one did you struggle with? There's the general solution, equations, okay? All right, we can have a look at that after question 9. Thanks, Mr. Hugo. All right, I'm seeing question 9 here, Mr. Hugo. What about you?
I also think question 9, and I think we should get started before time
Awesome.
catches.
Right, let's go. Question 9. So we're going paper 2, we're going question 9. All right. Okay, so we need to prove a theorem. Okay, it's our proving of a theorem question, guys. This proving of a theorem question, this you guys need to study. So to go through this is going to waste your time. I'm going to say to you, guys, please go study how to prove a theorem. All right, it's really important. You need to know how to prove that theorem. For me to go through this with you again is going to waste your time. What I want to go through in question 9 is the actual questions, which I'm guessing is what you struggled with. So because you proved the theorem before, remember that that's what's going to now apply in the question below. Let's have a look at 9.2.1. In the figure, QS and PR are the diameters of the circle with center O such that PQ is parallel to SR. I told you earlier, make sure you do it, you highlight your parallel lines. So PQ is parallel to SR. There's PQ, there is SR. PS is produced to T, so PS is produced to T, and N is a point on the circle such that Q1 is equal to Q2. So I've got Q1 equal to Q2. Guys, do you see that that is not drawn? All right, so that's going to make your life a lot easier to draw it on for yourself. That happens sometimes. They don't tell you that. So Q1 is equal to Q2. Okay. Sn is drawn. Rs intersects Qn at M, and S1 equals 48 degrees. So determine with reasons the size of Q1. That's the first thing we need to do. We need to work out what size Q1 is. So if I'm looking at this, okay, if I am looking at this and I want to work out what Q1 is, all right, I am looking at my all the reasons that they've given me. All right, I'm looking at the only actual number that they've given me, and the only actual number that they've given me is this one over here, 48 degrees. And if I'm looking at that, could I perhaps use tan chord theorem? Yes, I can, okay? This figure is sitting on the outside, and here is the line that it's sitting on, guys. So if I follow this line to the angle that it's making, look. All right, look at that, okay? It's making that angle over there. All right. However, all right, what is this the exterior angle of? So we need to be careful. We need to be careful that we don't get stuck as well. Because what is that an exterior angle of? It's not just an exterior angle of the triangle. It's not making an exterior angle of a triangle. It's very easy to get stuck into tan chord theorem and that trap. The question before was on cyclic quads. What is this an exterior angle of, guys? It's an exterior angle of, what is this whole shape? This whole shape, all right? This whole shape is a, what? Tell us in the chat. Tell us in the chat. You've been so quiet today. Tell us in the chat. What is this shape that is an exterior angle of? A cyclic quad. Thank you. So that is an exterior angle of a cyclic quad. If that is 48 degrees, what do we know? That exterior angle is equal to the interior opposite angle. So we know that angle, so for 9.2.1, we know that angle S1 is equal to angle PQN. Reason, exterior angle cyclic quad. All right. We also know that Q1 equals Q2, which is going to be equal to 24 degrees. Reason, QS bisects QN bisects angle PQN. How do I know that? Because they told me, it was given. You could also say given. All right. Next question says, what is equal to angle R? So here is angle R over here. All right. Looking at angle R, it's made by these 2 points. So here are the 2 points that make it. I'm going to drag them up to angle R. What other angle does it make? It also makes angle Q1. So that means this was A or B. I'm going to say angle R is equal to angle Q1, which equals 24 degrees. Reason, angles in same segment. All right. Angle C, or sorry, C is looking for angle M1. So there is angle M1 over there. There is angle M1 over there. Okay. If I'm looking for angle M1, well, do I see that angle M1 is sitting on my parallel line, guys? That's what's giving it away. It's sitting on the parallel line. What else is sitting on the parallel line? So angle M1 is going to be equal to what? It's going to be equal to angle PQN, which is equal to 48 degrees. Reason, corresponding angles. It's sitting on that parallel line. PQ is parallel to RS. Okay. Gives it away, sitting on the parallel line. Right. My last question here. Prove that ST is a tangent to the circle passing through M, N, and S. So M, N, and S, here is my circle. And they want me to prove that ST is a tangent to that circle. In other words, what do we need to know? We've got to have our tan chord theorem. Okay, so we know for 9.2.2, we can say, well, angle M1 is equal to angle S1, which equals 48 degrees. Therefore, ST is a tangent. Reason, converse of tan chord theorem. So tips that Mr. Hugo and I can give you here, whatever they've asked you to prove, the theorem they've asked you to prove, guys, you're going to use that to answer your question. All right, we wanted to go up to the trigonometry and the trigonometry equations, I think it was, from Cassandra. So Cassandra, let's go have a look at which trigonometry equations you wanted to go through. So we went through that together, we went through that one together, we went through this one together. You didn't want to go through the trig graph, okay? That was not trig equations. All right. Maybe I've missed the trig equations. Let's go back quickly. All right, so we went through that together, we went through that together. All right, here we go. It was these two, okay? So question 4. I hope that I'm right, Cassandra. I hope that those were the ones that you wanted to go through. Mr. Hugo, do those seem like the ones that Cassandra wanted?
It was the best I could figure out as well, yes.
Awesome. Right, so we're going to go through question 4 for Cassandra. All right, we already did question 4.1 together, guys. We did those last week. If you're not sure, please go back and watch the video from last week. Let's have a look at 4.2 and 4.3. Okay, so 4.2. So in 4.2, we have the following. We've got the tan of negative 315 degrees minus the cos of 780 degrees. And if I'm not mistaken, it tells us very clearly in question 4, because it always does, without the use of a calculator. Okay, so let's go double check. Without using a calculator, Okay, so the first thing we want to do is we want to get it out of being negative. Okay, so we want to get it out of being negative. All right, so the best way to do that, and the best way I can suggest to do that, is saying tan of negative 315 degrees. And all you need to do that is you add 360. Okay, so when you want to get rid of the negative, you add 360. All right, minus. Okay, then you're going to say to yourself, all right, what is sorry, thinking too quickly. We've got the cos of 780 degrees. So I've got cos. All right, I'm going to go say to myself, okay, 780 minus 360. So on my calculator, go take it. Okay, guys, remember, whenever you're minusing or you're adding 360, you're not actually doing anything, because it just means you're going around to the exact same place. So 780 minus 360 gives me 420. I can still minus another 360, and it gives me 60 degrees. So I'm here. So far, I've got the tan of negative 315 plus 360. I'm staying in the same place. I'm just adding 360 to get it out of being a negative. And all I've done is I've gone and I've subtracted 360 and subtracted 360 to see where I am. So negative 315 plus 360 gives me tan of 45 degrees. Okay, minus cos of 60. All right. Now, okay, next thing we need to go work out for ourselves is the following. We need to say to ourselves, okay, you're not allowed to use a calculator. We get that. All right. So I have shown this to you guys before. I'm going to show you again in case there's anyone who wasn't here in the first term. Okay. You can go and you can draw yourself this little drawing on the side. All right. You can tell yourself this is 30, this is 45, this is 60, and this one will be 90. So here I've got 90, 60, 45, 30. This one will be 0. I'm going to open up some pointers here. Okay. All right. This is going to be, X value is going to be 0, 1, 2, 3, and 4. This is going to be 0, 1, 2, 3, and 4. And then what we're going to go do is we're going to square root everything. Okay. Along all of these, r is going to be equal to 2. Right, so reminding you again, this one is 0 degrees, this one is 30 degrees, this one's 45 degrees, this one is 60 degrees, and this one is 90 degrees. Okay, let's go see what I'm talking about now. Right, so I've got the tan of 45 degrees. Okay, so I always say shade, your rear, cos, x-rays, tan, your exterior. So this one's going to be your exterior. Okay, shade, your rear, cos, x-rays. Okay, so I'm going to 45. Here is 45 over here. I need to take y over x. So my y is the root of 2 over the root of 2 minus. Cos, I need x over r. So my x value is root 1 over my r value is 2. Root 2 over root 2 gives me 1 minus root 1 over 2 gives me a half, and that is equal to a half. Guys, that's the best way that you can do it without showing a calculator. If you know how to remember them in your head, by all means, remember them in your head. Okay, I'm going to give you 2 seconds to take a screenshot if you weren't in our June workshop. All right, this is the best way that I can always use to remember it. This is the way that gives you the full marks because it means that you aren't using your calculator. Okay, it means that if you need to go and rationalize something, you're rationalizing something. You are doing it the proper way without using your calculator. Of course, we all know that you guys are going to go try and use your calculator. However, this is the best way to do it. Okay. All right. I hope that you've got that down in a screenshot. Okay. All right. I'm going to make it a little bit smaller. 4.3. Okay, for 4.3, I just want to make sure I've got the right question for 4.3. So let's go take this question down. 4.3, determine the general solution of that. Okay, so 4.3, I've got 2 sin x times cos x equals cos x. Well, if I'm doing general solution, okay, I want to take everything over to one side. So I'm doing general solution, it's going to make my life a lot easier. All right, so what I'm going to do is I'm going to have 2 sin x times cos x minus cos x equals 1. That means that what I'm going to be able to do now is I'm going to pull cos x out as a common factor. And it's going to leave me with 2 sin x minus 1. Apologies. See, I almost made the same mistake as earlier, and then I get confused. Equals 0. Okay. That means that I can say, therefore, cos x equals 0, or 2 sin x equals 0. Okay? If cos x is equal to 0, all right, on my calculator, shift cos of 0 equals, and I get x equals 90 degrees plus k times 360. And I must always remember k is an element of real numbers. Or x equals 90 degrees plus 180, 270 degrees plus k times 360. K is an element of real numbers. All right, I'm going to take this guy, I'm going to do it in blue, and I'm going to bring him down here. Okay, so I've got, I left out the minus 1 here. I've got 2 sin x minus 1 equals 0. 2 sin x equals 1. So sine x equals a half, hey? So therefore, on my calculator, shift sine of the half equals, and I get x equals 90 degrees plus k times 360. K is an element of z, or, apologies, x equals 150 degrees plus k times 360. K is an element of z. Apologies. Okay. All right. After we factorize, do we just say that they equal 0? Yeah, because when you factorize, you do make them equal to 0, because that's what factorizing is. For Kaz, can we just say plus or minus 90 degrees? No, because you want to say positive. They don't speak to you about being in a negative. No, so no. All right, guys, we have 2 minutes left. Is there anything that you want to ask about exams, about any tips or tricks in the last 2 minutes? Anyone for the last 2 minutes? Mr. Hugo has put some really useful tips and tricks here. He has also put the link for Watobe Wizard for you guys, which is also really great. Please go use that. Okay, go use the Watobe Wizard, please. All right, make sure you're using it. Mr. Hugo, anything from you?
Yes, in this last minute, I just want to ask everybody take a quick screenshot of what is on the screen now, if they were still writing. And then if Teacher Kirsty could maybe go back to that one question that we were all struggling with earlier, not necessarily to complete it right now, but I want to, first of all, thank everybody for their perseverance in the last 3 lessons, these last 3 weeks, the last 3 weekends that you guys were working so hard on maths. Guys, I've learned over the years that hard work pays off, and math is not something we can just go study. Math is something that we have to practice, and that is something that you all have been doing for sure. Now, furthermore, I want to ask you if Teacher Kirsty can show us that question again. Take a screenshot of that, guys, and then go ask the bot for help, okay? So that's the little bit of homework that we are giving you today. Please go ask the bot, and then I'm sure that's what Teacher Kirsty and I are also going to go do now. We're going to go ask the bot. Just because math minds are inquisitive minds, we are going to go find the correct answer, and we are going to go figure that out. And I'm sure the bot will guide us through the questions. The bot, guys, sorry, I keep on saying the bot because that's what we used to call it, but I'm referring to the wizard, okay? So I have posted all the links. If you're not familiar with the wizard yet, go give that a try, and then take a screenshot of this question that Teacher Kirsty is still finding, and then we go figure out the correct answer for that. Thanks again, everybody, and I really enjoyed being here with you in this boot camps, and I wish you all the best for the exams.
Thank you so much, Mr. Hugo. Right, guys, I'm going to go back to that question for you. All right, and let's go see if I had gotten all the question right. Okay, so let's go over it again. Right, so we took the questions and we broke it down into making it equal to y. Once we had them equal to y, we made them equal to each other, okay? We then took the question, all right, and we got rid of the negative. So now we have it all equal as follows, all right? Now, okay, what do we now need to do? Now, it's important that we solve for k, okay? So that's what our aim is here. We need to solve for k here, all right? So if we're doing this, okay, if we are doing this, all right, let's go and work out a way for us to get this done, okay? So I'm going to go and I'm going to say to myself, all right, that I'm going to have this on its own, minus 4x on its own, okay? And I'm going to leave this negative here, and I'm going to have 16 minus k equals 0. Why am I doing that? Okay, because I'm turning it into an equation for myself now. All right, so now, okay, and actually, I'm going to go all the way back up to here. Apologies, guys. This is what I'm going to do. Remember earlier on, I said to you, I've done something wrong. So I'm going back up here. Okay, I'm going up to this original one where I took it across. Okay, right. So again, I've got negative x squared plus 4x. I'm going to keep this like he is, okay, plus, but I'm going to say this, 16 minus, okay, equals 0. Okay, so technically, it's kind of like this is my a value. So this is my a. Okay, let's see, sorry. This is going to be my b. I'm hoping this is making sense to you guys. And this is going to be like my c value. All right, I'm hoping that makes sense to you. Okay, I'm hoping this makes sense to you. All right, okay, so, all right. If I'm then trying to put my figures into that, okay, all right, I'm going to go say to myself, okay, all right, I need to have equal roots. So in order to have equal roots, what do I know I need to have? I know I need to have b squared minus 4ac equal to 0. Hey, do you agree with that? B squared minus 4ac equals 0. Remember I said to you earlier on, in order for the tangent to have equal roots, in order for the tangent to be equal at one point, there must be equal roots. Remember we spoke about that. For the tangent to have for the tangent to touch at one point, it must have equal roots. So therefore, it means that b squared minus 4ac must be equal to 0. So I think that out for you guys. That means that my b value, which is 4 squared minus 4, my a value is negative 1, and my c value there, okay, is 16 minus k. And I'm making that equal to 0. I'm hoping this makes sense. I know it's a level 4 question, but remember, in order for the tangents to have one point of intersection, they must have equal roots. So b squared minus 4ac must be equal to 0. I've gone, I plotted it out. That was my a value, my b value, and my c value. Okay, so I've got 16, all right. Negative times negative is a positive. 4 times by 16 gives me 64. And negative times positive gives me negative 4k equals 0. All right. 16 plus that gives me 80. I'm going to take that across to the other side. Therefore, k will be equal to 20. Okay. All right. I hope that that makes sense. I hope that that makes sense. All right. I'm going to say it one last time. In order for the tangents, okay, to have one point of intersection, it must have 2 equal roots. For there to be 2 equal roots, b squared minus 4ac must be equal to 0. I took my equation, I figured out which was a, which was b, which was c. I put it into my equation, okay, and I got those values. All right.